here we have some statics examples. A particle is acted upon by three forces, F, G and H. F has a magnitude of 40 newtons, acting to the right and down at 45 degrees to the horizontal. G has 60 newtons and is directed to the right and up 30 degrees. Now we find the magnitude and direction of H. Here our axes are, this is just to show our direction for our axes, I and J. So G is here, going upwards, like we said, 30 degrees, and the F is going down from our I direction, is going down here by 45 degrees. So we know that our magnitudes of F equals 40 and G equals 60, because these are our magnitudes here in newtons. So moving on, F makes an angle of negative 45 degrees to the I direction. So F equals the magnitude of F cosine negative 45 degrees I, and same again likewise for sine negative 45 degrees I, because cosine of 45, sine of 45 both equals 1 over root 2, but this one just with the negative, we get this. Now for G, we will show this pictorially here. So G equals 60 sine 30 I plus 60 cosine 30J. Now sine of 30, cosine of 30 are standard angles again, so we have exact solutions here. So which gives us this. Now to find H, we know from our equilibrium condition here that H equals minus F minus G from this. So putting this together, multiplying out, collecting terms, we get this. So for H here, it will be acting, is given pictorially here, and these are the values we found. So H is acting down by this angle, and our magnitude is given here, 62.910 ... So our tangent is this, dividing one by the other. So to find the angle is again the inverse tangent of 22 point so and so. So H has a magnitude of 63 newtons and is directed to the left and down at 22 degrees. Now here's another example. Now if it's not pointing to the right, we can always rotate axes, because axes are made up. In our coordinate systems are invented by humans just for convenience, so we can do whatever we want with our coordinates. So in this instance, we're going to rotate it here. So now our magnitudes are 5 and 9. So again, that would be in newtons. So F equals negative 5, acting in negative 5J. So we can draw it here pictorially with these angles. 9 of sine of 60, 9 cosine of 60, and our F is going down here at 60 degrees, and our magnitudes are here. So from this axis here, we're just drawing off these angles from this force diagram that we've shown here. So now G equals in our components of minus 9 sine 60 degrees I plus 9 cosine 60 degrees J, which is again our regular analytic angles, analytically solvable angles, just to make it simple and straightforward. So our final result is this here. And yeah, that's it. So please do like and subscribe, and I've got plenty more to come.